recording. There we go. Okay, so we're on number 17 on section 4-1. So, good discussions, though. I thought that was, that's one thing I like about this class is that you guys are seniors and we can have these discussions and so forth about stuff that's not necessarily math, but it's still interesting stuff. So, number 17, plus you guys like to stall, so you don't have to do as much work, right? You ain't that smart. I know what's going on, but... Okay, so they said use the theorem on inverse functions to prove that f and g's are inverse functions of each other. And it's a sketch of graphs. We're not going to sketch them. So they give us two functions here. They say f of x equals 3x minus 2, and then they give us g of x is x plus 2 over 3. Okay, so an inverse, I want to make sure we haven't forgotten what an inverse function is. What would be the inverse? Here's a function. Let's say the function is you put on your shirt and then put on your pants. What would be the inverse of putting on your shirt and then putting on your pants? Take off your pants and take off your shirt, in that order. So inverse means you do the opposite thing in the opposite order. It's just undoing, it's hit and rewind. That's all you're doing, you're rewinding the film. That's all it is, okay? So, for example, these are inverses because if I give you a number for x, okay? If I give you a number for x, what would be, if you plugged it in, if I said x is 5, you plug it in, what would be the first thing you do with 5 after you plug it in? You times by 3, and then what? And then you minus 2. If you plug in a number for x, the first thing you do is what? Add 2, and then what? Divide by 3. So instead of timesing 3, subtracting 2, then you add 2 and divide by 3. You're back where you start. If I take some number, if I take the number 5, 5, if you times it by 3, you have 15. Minus 2 is 13. 13 plus 2 is 15. 15 divided by 3 is, we're back to 5. It just undoes what you did, okay? Now, we didn't prove that they're inverses, okay? What you need to understand, though, is this. When you plug in a number, and then you plug in the number into its inverse, you're back where you start. They just cancel each other out, okay? So here's how you do it. And I'll be honest, I'm not sure about this, okay? I was taught in college, I'm going to use one of your guys' brothers as an example again, okay? If I told you that Cal is a twin of Max, in my opinion, you don't need to also prove that Max is a twin of Cal. It's not really necessary. You can do it, but I don't think it's necessary. And why do I bring that up? If F is an inverse of G, I don't know how G can't be an inverse of F. I don't know how. That's the way I'm sure I was taught that in college. But in this textbook that I photocopy for you guys here to do these, it wants you to do it both ways. I'm not going to make you do. I don't think it's necessary. Okay. So it's like, again, if I talk to Max Bigelow and I ask him, he tells me he's a twin, and the twin is Cal. Do I need to go find Cal and ask him the same question? No, I don't. I can, but I don't think it's necessary. It's unnecessary. Okay. Good. We were waiting for you. Now we're ready to go on the first question. Okay, so here's what we do. We simply plug this in, either plug in this into the f function or the f function into the g function. It doesn't matter. It doesn't, okay? So here's what I'm going to do. I'm going to take this function and plug it in for x. Plug it in for x. So we have 3 times what? What did we plug in for x? X plus 2 over 3. Minus 2. Okay? And if we do that, let's clean this up. Anything cancel? Out these 3's. And we're left with x plus 2 minus 2, which is what? X. And that's what we're supposed to get. We're supposed to get whatever we start with. No matter what we plug in for x, you're going to get the same thing at the end. We could have done it the other way. We could have plugged this in for x here. If I did that, we're going to plug in 3x minus 2 for this. You would have had 3x minus 2 plus 2 divided by 3. Minus 2 and plus 2 cancel, so you have 3x over 3, which is x. So in order to be inverses, you plug one function into the other one, and you need to get what for an answer? X. And again, the book says do it both ways. I don't care which way you do it. I really don't, okay? All right, let's look at number 19. Okay, number 19, they give us f of x is negative x squared plus 3. And then g of x is what? Wait, I got 3 minus x. Okay, so I'm going to do this. I'm going to plug in this. Well, I'm going to plug this one in here. I'm going to plug that in. It doesn't matter. It doesn't matter which way you go, okay? So let's do that. We have radical 3 minus all of this. So put negative x squared plus 3. I just plugged all of that in for x. Let's clean this up. Distribute the negative sign. Minus minus is plus plus. Minus 3. We put together 3 and negative 3. Those cancel. So we have radical x squared, and radical x squared is x. We're just proving, they're saying these are inverses. Prove it, okay? So again, like for example, using Callum Max Bigelow. If I said they're twins, prove it. How can I prove it? Show me your birth certificates. Hey, same birth date, same mother, same place, okay? That proves they're twins, unless they forged them, okay? Okay, cross off 21, 22, 23, and 24. We're not doing that, okay? All right, they want you to find the inverse function, okay? Find the inverse function. So, it says f of x equals 3x plus 5. Okay, so real quick here, let's make sure we haven't forgotten how to do this. If I give you this right here, if I gave you 3, 7, 2, 8, is that a function? Yeah. The inverse of it is real simple. The inverse is 7, 3, 8, 2. What do I do? Flip what? X and Y. X becomes Y, Y becomes X. That's all you do, okay? Is that a function? Yeah. Okay? If it's a one-to-one function, then it has an inverse, okay? So on this one, first off, keep in mind what we just said. How did I find the inverse? I switched X and Y. Keep that in mind. When I see f of x, I can cross that out and make it what?
Y.
What's the inverse of y equals 3x plus 5?
Equals 3y plus 5.
What'd you do?
Switch them.
Swatch x and y. X equals 3y plus 5. Now you're not done. It's not quite that easy, okay? And then you solve for either x or y. You solve for either x or y, okay? And what do you think you solve for x? I mean, it's all right now. Here's a clue. You're not done. You're not done with this question. Do you solve for x or do you solve for y?
Both.
X. Because Y.
I'm going to say it one more time. You're not done. How come you don't solve for x then?
You're trying to find
Okay, let me give you a clue right here. 3x plus 1 equals 7. Okay? We're getting very basic here. I'm not making fun here. How do I solve that?
Minus 1.
Minus 1. 3x is 6. Are we done? How come? Why?
Where x by itself.
Oh, got x by itself. In order to be done, you got to get x by itself. Why can't we solve? Why can't we solve this for x?
Because
X of x.
What would you have to do?
nothing.
And what did I tell you? You're done?
No.
You're not done. Okay? If it said solve for x, you'd be done. All done. Nope, you got to solve for y. Okay? So, we minus 5 to each side. So x minus 5 is 3y. Last thing we do is divide by 3. Now it's going to say x minus 5 over 3 equals y. Look back at the original problem. You really shouldn't have that there, okay? There's no y in the original problem. It doesn't say y, it said what? F of x. So let's put f of x, but we're still not done, okay? It's not f of x. It's not even g, well, you could say g of x, meaning say different function. Right, you put, this is, because f of x is 3x plus 5. This is the inverse of f of x. So you put a negative 1, but you don't put the negative 1 here, you put it right here. That's the symbol for inverse, okay? And does it make sense that that's the inverse? Let's talk about this. You plug in a value for x, you do two things to it. What's the first thing you do on the original problem? Times 3, and then what? Add 5. Do the opposite in reverse. What's the opposite reverse of timesing 3, adding 5? Minusing 5 and dividing 3. You minus 5, you divide by 3. That's the inverse. If I plug this into this and simplified, what would you get? X. How about that into this? Still get x. You don't need to do that. Okay? Okay. You're just undoing what you did. That's what an inverse is. Okay, how about number 27? They're going to get tougher. 25 was an easy one. 27 is going to get a little tougher. I'm going to make it y equals 1 over 3x minus 2. First step's easy. What do we do first?
Put the Y.
Put the y what?
Put the X and Y.
Flip the x and y. Yep. Flip the x and y. So we're gonna have x equals 1 over 3y minus 2. And this will be the last time I ask this because we just talked about it just 2 minutes ago. What do we solve for, x or y?
For
The y. How come we don't solve for x?
because we're trying to solve for y.
How come? How come we
Right, so.
Yeah, what would you do to solve for x? Nothing. You'd be done, and you're not done. You gotta solve for y. Okay, this is gonna be a little tougher. Okay.
Multiply both sides by 3y.
What?
Multiply both sides by 3y minus 2.
Very good, but here's what we're gonna do. Okay, that's the long way. Okay, and there's nothing wrong with that. That's exactly what I was hoping you were gonna say. Very good. Okay, I'm gonna show you a little shortcut here. Okay, just watch. Just watch. Don't write this down. We're gonna times this side by 3y minus 2, times this side by 3y minus 2. Okay, so these things cancel. Don't write this down. End up with 3y minus 2 times x equals 1. Okay? Now you could distribute that x. You could do that. You could definitely do that, okay? But we could do something else. We want to get y by itself. I could get rid of that x right now. What could I do to get rid of that x? Don't say minus, not minus.
Divide.
Divide. How come divide?
Because it makes minus 1.
How do you know it's times?
Because that's how you make it.
Parentheses. So you could divide by x. I told you not to write this. So you have 3y minus 2 is 1 over x. The last thing you wrote was this. And I said, don't write anymore. You think of a much quicker way of doing to get from here to here?
Swap the bottom and
Just flop, switch these, switch those, okay? And I'll show you how that works. You guys agree that 5 equals 1, let's see, 10 over 2?
Yeah.
Is 2 equal to 10 divided by 5?
Yeah.
What did I do? Just switch those, you can do that, okay? You can do that, all right? So we just flip-flop these. So if you want to do all that, what you said was perfect. It's a lot of extra work though, okay? So, that's the thing I like about this class is there's things I show you guys that I would never show Algebra 2 that. They wouldn't get it, okay? Some would, but most wouldn't, okay? So let's just switch them. So 3y minus 2 equals 1 over x. Now what? What's your goal? What are you trying to do? Get y by itself, so plus 2. So plus 2, plus 2. So you have 3y equals 1 over x plus 2 off to the side. One last thing. Divide by 3, divide the whole thing by 3. So y equals 1 over x plus 2, all that over 3. But it shouldn't be y, it should be what? F inverse of x. I mean, it looks like f to the negative first power. It's f inverse. Is the way you say it. Okay, so that's a little tougher question. 29. This is even tougher yet. So y equals 3x plus 2 over 2x minus 5. To be honest, it's been a few years since I did this problem. I think I remember how to do it. We'll see. First step's easy. What do?
Switch.
Switch them. So x equals 3y plus 2 over 2y minus 5.
But now, why would you want to do what we did last time?
I don't think so.
Because both the y's are already on the same
Yeah,
side.
I don't think we want to do that in this one because we got a y on top. I don't think you want to do that. So I think we should do what you did. Okay? So do what?
Multiply the bottom by both sides.
Times by what?
Multiply by the bottom.
So 2y minus 5? Good. Times 2y minus 5 times 2y minus 5. Okay? So these cancel it off with 3y plus 2 on the right. And we are going to distribute, yeah, this is not that bad. Okay? It's a little, we haven't done this year. It's going to be a little weird, but it'll be all right. Let's distribute the x. So x times 2y is 2xy minus 5 times x. We just distribute the x. Now, I want to see if you guys can figure out, I'm going to tell you what to do. I want to see if you guys can figure out why I'm doing what I did. Okay? I'm going to tell you, here's what you do. You guys see if you can figure out why I'm doing it. Huh? I would write this down, yeah. This is the way we're going to do it. I can't think of a shorter way of doing this. It's not a short question. So here's what we're going to do. We're trying to solve for y. We're going to solve for y. So here's what I'm going to do. I'm going to minus 3y on this side and this side. I'm going to add 5x on this side and this side. What would that accomplish if I subtracted 3y to each side and added 5x to each side. If we do that, these are gonna cancel, and we're left with 2xy minus 3y equals, these are gonna cancel, 2 plus 5x.
All the Y's are on.
Keep talking, all the y's on one side, and,
X is still over.
well,
Because there's still.
the stuff with y's is on one side.
Can you subtract 2x?
You can
Uh,
subtract 2x.
no, hang on, time out, hang on a second. He's right, you had to go further than that, though. He said we had all the y's on one side. What's on the other side?
So, just that?
Well, why didn't I keep this over here? Why did I add 5x? Why didn't I,
Get rid of it on the left side, right?
why did I want to get rid of it?
You want
Trying to
the
get
left
it
side?
away from the
Because you're
left.
trying to get X by itself.
Not x by itself, trying to go y by itself.
Oh, yeah.
Okay? So hoping somebody, you guys are close. He was very close when he said we got all the y's on one side. So why did I move this?
All the X's are there?
Because it doesn't have a Y.
There's no y's. All the y's are on this side. The stuff over here is the stuff that's ain't got no y's. No y's, okay? Get all the y's on one side, all the non-y's on the other. Now, you can't subtract 2x, okay? At this point, you might be stuck. You might be stuck. We're not. You might be like, I'm not sure what to do here. We're gonna factor. It's easy factoring though. What could I factor out of each of these? A y. Times what?
2x.
2x minus 3 equals 2 plus 5x. We got one last step now. I want to get y by itself. It's the last thing you have to do.
Divide 2x is.
Divide by 2x minus 3. Divide by 2x minus 3. So it says y, but it's not y. It's f inverse of x. It's 2 plus 5x, or 2x minus 3. One more thing. I wish I would have said this earlier, and I didn't. Some students might think this, okay? And I like to always show this because it lets me show off my great English skills. Well, I'd be a phenomenal English teacher, not really. Some students would say this. We would do what Luke said, 2y minus 5, and then, let's see. Why can't, okay, at this point, when we had 2xy minus 5x equals 3y plus 2. At this step right here, before I showed you what to do, some students might say, why don't we just do this? Let's add 5x, We have 2xy equals 3y plus 5x plus 2, and then divide by 2x. Divide by 2x. Y equals 3y plus 5x plus 2 over 2x. Why can't we just do that?
There's a Y on ours.
Is that a problem?
Yeah.
Yes, it is. And here's the English thing, the one thing I remember from English. I'm asking you what y is. I'm kind of asking you for the definition of what y is.
Can't define.
What's the one rule about definitions?
It can't include itself.
If I define the word desk, there's one word I can't use in it.
It's a desk.
Desk. You can't say, well, a desk is kind of like a square desk thing. You can't do that, okay? So if I want to know what y is, what can't you use in your explanation? The letter y. You can't have a y in there. You can't do that. Have I talked to you guys about that before? Or not? Oh, okay. Thought maybe I mentioned that last year. So that's the one thing I remember from English class. Oh, I do remember two things from English class. Actually, two things. That when people say, when somebody says they're done, like I'm done, whatever, I'm done working, food is done, people are finished. I remember that. People are not done, people are finished. Food is done, people are finished.
Actions can be done.
Huh?
Actions can be done.
I just remember our English teacher would always say that. You can't be, a person is never done, a person is finished. Food is done.
I don't get this one.
When you say I'm done with my homework, apparently that's incorrect. I'm finished with my homework, is what you're supposed to say. You're not done, you're finished.
Well, no, because it's not the person that's done, it's the action of it being done.
I just said, this is what I hate about English.
It doesn't make sense, yeah.
Well, no. Why do they say that? I mean, for example, they say ain't isn't a word. You know why the ain't isn't a word? Because somebody said way back when the ain't is not a word.
Even though it's in the dictionary.
Yeah, right. I mean, it's like, and all these rules, and I get it, you have to have certain rules in order to communicate, I get that. But it's like, when somebody writes a sentence and somebody else says, no, that's not written very well. It's so subjective. It's not my opinion that 1 + 1 is 2. It is. He has a 400-page book that would explain that 1 + 1 is 2, right? So, but it's not somebody's opinion. So
No,
English is very subjective.
I had an English teacher, and his dad was a professor in English and on gifted, and wrote several books on teaching gifted students.
Uh-huh.
And this teacher, who, grew up with this, he was like, English has no pattern. I'm just gonna say it.
Oh yeah, no, there's
It's
all
a
kinds of
mess.
weird rules. But even then though, even other languages, when they say this is the way, it's somebody's opinion that they do that, Math is not opinion, it's factual. And that's why, when it goes into other things like sports, nothing against, but like competitive cheer. I don't know anything about it, but a sport like that, like competitive cheer or diving or gymnastics, I don't like those because it's subjective.
I gotta say.
In volleyball, well, there's a little bit, the officials have to make judgment calls, but if they think it's in, they may mess up on it, but if it's out and they go, well, we're gonna give them a point anyhow because we're just gonna give them a point. You can't do, it's not subjective. It's either in or it's out. If they get it, they might get it wrong, but it's not their opinion that it's in or out. I mean, it's what they think. You know what I'm saying? Though, but like competitive cheer,
So you
it's
hate-
subjective.
You hate like gymnastics.
I appreciate, they're phenomenal athletes, okay? And I think it's entertaining to watch. I just don't like sports that are judgmental like that, where they think, somebody's opinion is that they won, In a football game, the scoreboard tells you, a basketball game, it tells you, the ball goes through the rim, you get 2 points. It's not like, ooh, he shot it really cool. It didn't go in, but we're gonna give him a couple points because it looked cool. No, if it don't go in, I don't care how cool it looks. You don't get any points. If you don't get the ball across in the end zone, you don't get the points. Okay, so that's just.
The